I'll just give a brief intro about you, Aakanksha, then we will begin with the presentation.
Okay, okay, sure.
Mhm. So, good afternoon, one and all present here. Uh, I would like to give a brief intro about our speaker, Ms. Aakanksha Kumari. She is currently pursuing her PhD in IIT Delhi. That is actually a joint research program between University of Queensland and Indian Institute of Delhi. She is working with lake sediments to understand the paleoclimatic studies, and she is holding a master's and bachelor's degree in chemistry. This is a brief intro about Ms. Ratakshna. Now we would like to begin the session. The session is about how to harness ArcGIS, QGIS, and it's for remote sensing applications. It's a hands-on approach, and the for participants inside the Teams link, you can Q&A box is also enabled for you posting your queries. If you have any queries, you can just post the questions, and the speaker will answer all your questions there. Rakansha, over to you.
Okay, thank you for the
Thank you.
intro. Yeah,
Thank
so
you.
in today's session, uh, I will try to use ArcGIS, QGIS, and DIPS for remote sensing application, and I'll show you how to do it. And then later on, you can try and do it. And if you have any doubts, you can ask me. Okay. So first of all, I wanted to know like how many of you have done any remote sensing course? So you can answer in the chat box.
Or you can just raise your hands even.
Yeah,
An
yeah, yeah.
option is there.
Yeah,
Yeah.
yeah, yeah. Or raise your hand. So anyone? Yeah. So only one person. Okay. So in this session, I'll first start with the basic, and there is one question for you. So tell me, how many of you know that we humans are the natural remote sensing expert from our childhood, and we don't use any gadgets or tool, but we do remote sensing? So tell me, anyone knows how we do remote sensing? How are we expert in that? So, or maybe you can, anyone can unmute and tell me. So, Rajlakshmi ma'am, is the option for chatting available?
Yes,
Because
yes.
yeah, I can't see. Um,
Is it you couldn't see the chat?
yeah, 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 yeah. I can't see the chat.
It's there. You just check it here. Has it been disabled?
Oh no, for
So,
me, like I can't see if anyone replied or not while I'm presenting. So
while presenting, you will not be able to see. You'll have to move
okay,
into the Teams, then only you'll be able to see.
yeah, yeah, yeah. So like, so anyone knows that we are natural remote sensing experts. So I'll tell you that we have five senses, and how many of these sensors do we use as remote sensors? So I think this question you'll be able to answer if you know what is remote sensing. So first of all, I'll tell you that remote sensing is uh, made up of two words, which is remote and sensing. And remote means far away, and sensing means feel, understand, or measure. So remote sensing means sensing things from a distance. Okay. So now I think you should be able to tell like how many of our five senses we can use as remote sensor. So tell me the number: one, two, three, or five, or four. Anyone? Okay, so no one answered. Raj Lakshmi ma'am, maybe you can tell. So, am I audible?
Yes, yes, you are audible. You are audible.
Okay, okay, okay. So, are my
We'll
questions?
wait. Yeah, yeah, yeah. We'll
So,
wait. Let us see.
yeah, so I thought students will be answering it, but I guess I only have to do it, right?
Maybe.
So, so the thing is, out of these five senses, three of them are we use as remote sensor. So the first one is sight. So our eye is one remote sensor, and hearing. So without being physical touch with the object, we can identify the object or measure it or understand it by watching it, hearing it, smelling it. So these three sensors are remote sensors. Okay. So I think the what is sensor or what is remote sensing, you know. So anything that we can see or like understand or measure without being physically in touch with it. Okay. So this is remote sensing. And like similar to this concept, like if you think how we can see any object. So, if you have read in your science classes that light falls on the object, so right now you can think that light is falling on this screen, and that then going back to our eyes, and there are sensors and transmitters which are connected to brain which interpret the image. So, this is the principle behind remote sensing. So, if we go by definition, remote sensing is the science and art of obtaining information about an object, area, or phenomena through an analysis of data acquired by the device that is not in direct contact with the area, object, or phenomena under investigation. So, the satellites or any remote sensing device is based on the principle which is like similar to that of our eye. So what happens is that any energy source, like if you consider our solar system, then sun is the um, greatest source of energy, and from this source of energy electromagnetic waves goes and comes, and then it interacts with the atmosphere, and then it interacts with the target, and then goes to the sensors. It is sensed, and data is recorded, and then the data is transmitted to the ground receiving stations, and then we use this data, analyze it, process it, and then use it for various applications. So these are the things that I told you. Okay, so you can go through it, and now I want you to tell what is this image telling. So I don't know this time if anyone will respond or not. So I'll wait for a few seconds. So if you see this image, can you tell what are you watching, or what is this?
Maybe so much of satellites around the Earth.
Yeah. So now you have to
Was
answer.
it right?
Yeah, yeah, yeah. It's that only. So
Okay.
yeah, 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 it's correct. So now you can see like there are so many satellites around Earth, and according to this UNOOSA records, there are 8,261 satellites as of January 2022, and I don't know how much it is now, but this was the data that I got to know. So As of now, it will be more. So the question that comes in my mind is that why are we launching these many satellites and why we are investing so many money into like launching these satellites? Okay, so what do you think? Why we are sending these satellites? What information we can get, where we can apply? Any ideas or guesses?
I think a
So,
student has answered in chat.
okay, okay. So, I think,
For data acquisition is this reply.
okay. And what can we do with this data? Like any application that you know. So, from this data, what can we do? Anything that comes in your mind? So, for surveying, yes, correct. So, like these data can be used for various applications, like it can be used for defense. So, we can watch our neighboring countries like Pakistan, maybe. And if there are any security breaches, we can, like, without going to the border, we can collect the data and see whether there is any activity or not. So, and there are other applications that are listed here. So, in this, like from this satellite data, we have different layers of uh, information, and what we do is that we try to convert this data to user friendly products like these images through which you can understand what is happening easily. Okay, so in this session what I will do is that I'll show you how to download satellite data, and then how to do digital image processing. So in digital image processing we have different steps like image restoration, image enhancement, image classification, and in these ones we can like I will tell you how to do georeferencing, contrast stretching. So this through these techniques we can enhance the image for better classification. And then I'll tell you how to do LULC, like how to make LULC maps. So, and also I'll tell you how to create shape files or how to make spatial plots to do using interpolation techniques, and how to make digital elevation models. So, I don't know if I'll be able to cover these all or not. So, I will try to cover up to this part, NDVI, and in the next session I'll cover the other parts. Okay, so first of all, how to download data. So there is this site which is Earth Explorer website through which you can download the data. So what I'll do is that I will go on this website. So is this screen visible? I'm on one.
Yes, yes.
Yeah. Okay, thanks. So what I'll do is that I'll paste it in the chat box. So if you want, you can download it right now, or maybe you can download it later on. So first you have to create an account. So as I have already created an account, so I'll not create that. But if you have to download, you have to first create the account. Okay. Now here what you can do is that go to world features, and um, you can look for any area of interest for which you want to download the data. Okay, so any place in, so maybe I'll download it for this place. Okay, so so either you can um, search the feature, or you can just go here and use map. So what this will do is that this will select all the area that was there in this rectangle. Okay, and then you can go to data sets, and here you can see there are various types of data sets: aerial imagery, AVHRR, commercial satellites. Then you can go to Landsat. So I'll be downloading Landsat 8 data. So you can go here, Landsat collection 2 level 1, and you can select this. So Landsat 8.9 OLITRS is the latest one. So I have selected this one. Okay. And then you can go to results. So now you can see there are these data sets. Now what we have to do is that we have to see, oh, this one is covering this area. So first of all, go to the metadata. So it's here. So metadata provides information about like when this data was extracted, or when was it taken, and what is the cloud cover. So you can see in this one the cloud cover is 0. So that means the sky was clear. So you should always check whether this cloud cover is high or not. So this is almost, this is 0. So I can choose this data set. Okay. And now, oh, sorry. And now you can go to this option, which is for downloading, and go here, product options. So either you can download this whole collection and set it, or you can like download these band data sets. So this one is band 1, B1, B2, B3, B4, B6. Okay, so you can use this and then download it. So as I have already downloaded, so I will not download, but so these are the steps to download the data. Okay, so I'll go back to the slide. So I hope this was clear. Yeah. So through these steps, you can download the data. So the thing is, if you have downloaded the data, you should know what is the format and like what data looks like. So the satellite data are digital images, and they are different from photographic film or analog images because they are like these photographic films are like they have physically continuous things. Like if in this film, if you see the silver iodide grains are hit by the photons, and then there is reaction and it changes its colors. So the it does not depends on intensity. So any amount hits here, it will have any reaction and it will change. But in case of digital image, if you see, it has one smallest unit, so it is not continuous, it is discrete. And this smallest unit called as pixels, they record they record the changes based on the number of photons that are uh, hitting here. Okay, so if you see this image, Landsat image, and zoom in, you will see the pixels. So maybe I can show you here how pixels look like. So I'll open ArcMap and show you how these pixels look like. So it's opening. So I am opening one data set. So I'm adding this band 1 data, and if you zoom in, so if you see, there are these pixels. So is this visible? Oh, so if you see here, you can see it like there are these smaller units which are known as pixels, and each pixel in this digital image is assigned one numerical value, which is called as digital number. So this digital number signifies the intensity of the signal that is received by the sensor. So it will start from 0. So if it is 0, that means that pixel will be completely black, and it will go up to uh, the value which is depending on the resolution. So if it is an 8-bit image, it can go up to 255. Okay, so 255 means it will be white, and the middle values are showing different gray levels. Okay, so these digital numbers, based on the digital numbers, these gray levels are assigned in the digital image, and you can calculate the DN range using this formula. So if it is an 8-bit image, so it will start from 0 and go up to 2 to the power 8 minus 1. Okay, so for 8-bit image it will be 0 to 255. Okay, so this now you know what is the format of the data that we have downloaded. One more thing we need to know is that what is the resolution of the data set that you have downloaded. So there are 4 different kinds of resolution, and first one is spatial resolution, second one is temporal, third is radiometric, and fourth is spectral. So spatial resolution is related to the size of the pixel. So suppose if you see this one, you can see this is the smallest uh, pix, uh, or unit, which is called as pixel, and if this smallest unit is representing 1 meter of land surface area, that means this 1 meter is the spatial resolution of that data set. Okay, so you see, and in this one, 30 meter represents 1 pixel. So 1 pixel is representing 30 by 30 meter on the land surface area. So if this resolution or the value is lower, that means the picture will be clear and it will provide more details. Okay. And if the spatial resolution is coarser, so you can not identify the features which are less than 30 meters. Okay. So and the second, I was hearing something. I don't know. Am I
Your video
audible?
got struck. Yeah, in between your video and audio got struck.
Okay,
Maybe
okay.
some network issues.
Yeah. I think so. So I also heard something, so I thought, what is
Mhm.
happening? Yeah. So, okay. Now, the second kind of resolution is temporal resolution. So, it relates to the revisit time. So, if the satellite is visiting very frequently, then the data, like in this case, will be having more information as compared to this one. The third one is radiometric resolution. So, this relates to what value, like for case of 8-bit image, it will be having 256 different gray levels, and if it is 2-bit image, it will only be having 4 gray levels. So you will be only be having, like, you can think like if you only have 4 colors to draw something, then the image will be not that detailed, but if it will be having different colors, then it will be like more good. Okay. And the fourth one is uh, spectral resolution. So if the number of bands and the bandwidth is narrow, then the spectral resolution is good. Okay. So these are the resolution which you should uh, look at after downloading the data or before downloading the data. So based on the application, so suppose if you have to do some land cover mapping or of a higher of a large area, then you don't need that much of high resolution. You can go for coarser resolution. But if you are looking at weather forecasting or something like that, then you should go for this one, daily data, which will be having temporal resolution. So based on the application, you should look which one to choose. Okay. So for every data, you should look at what is the resolution, um, and what is the application. Okay. Now, the data which I downloaded was Landsat 8, and it has 11 bands. And you can see these are the wavelength ranges of those bands, and the spatial resolution is 30 meters. Okay, so for band 1 to band 7, the spatial resolution is 30 meters. Now, uh, after downloading the data, we need to process it. So we process it because we have to improve the pictorial information for interpretation, and we have to store it or transmit it, or we have to classify it using computers. Then we need to process it and enhance it for better classification and interpretation. So that's why we do digital image processing. So there is this one uh, link through which you can download digital image processing simulator. So this is not a software through which you can do digital image processing, but through this what you can do is that you can see what are the calculation that goes on. Like if you use software, you will just give input file and it will give you the output file. Okay, but if you use this one, what it will do is that it will show you what are the calculation that goes on in a software. So that's why I recommend this. that through this you can see how these calculations are done. So maybe this also I will paste in the chat box so that you can download. Okay. Now the other thing is you can also download this one, QGIS, which is an open software. So if you want to use ArcGIS, it requires license, and not all students have that. So I will tell uh, how to use ArcGIS as well as how to use QGIS, so that you can like choose whatever you want to use for your processing. Okay, so through this you can easily download the QGIS software. So this is the one software that you will use for your processing. Okay, and if you have ArcGIS you can use that one also. So now, so there are three steps to do digital image processing. So first one is image restoration. So suppose you have the data, but there are some problems due to which the stored data is radiometrically and geometrically not correct. So this I will tell you what it means. So then we have to restore the image, and then the second step is image enhancement. So after restoration you have to enhance the image so that you can better identify the features. And the third step is image classification. So you can classify the features which are within the image. So these are the three steps. So one by one I'll go through this. So first I'll tell you the theory behind these briefly, because you will be doing any course about that, and then I will tell you how using the software you can do it. Okay, so the first one is image restoration. So in this one, if you look at radiometric correction, so these are needed because sometimes what happens is that the sensor is not functioning correctly, or there is calibration or sensitivity is not that good. Then what happens is that the image that you get is not correct. So these can have stripes or some noises in the data that are introduced due to this sensors uh, calibration. So maybe I can use this DIPS, which is a simulator, to show you what is this. Okay, so can you see this DIPS noise equalizer? So if you see, it is uh, this there are how many pixels? There are 4 into 4 16 pixels, and then this is the image. So if you see this one, in one row all the values are 0 dn values. So these are the dn values, so all the values are 0. So you can think like, how can one row, like it is similar to this one. If you see, all of these are white, that means all the values are maybe 255 or something. That means these lines were not correctly detected by the detectors. Okay, so these values are not correct. So for uh, solving this problem, what we can do is that correct this, and this is the calculation that goes on. So what it does is that it takes the dn values of the upper pixel and the lower pixel and average it out, and then corrects the image. So you can see this one was 0, completely black, and now it has been corrected. So, so see, so uh, this is how in the software these type of errors are corrected. There can be error due to sun angles or topographic effect, and there can be errors due to atmospheric interferences. So there is this diffusion, scattering, and reflection here in the atmosphere due to gaseous particle and dust particles, and these can introduce some, um, as you see in this image, there is something, I think it is effect of some kind of haze or something. So these things needs to be corrected because these are not containing the properties of the target. It is getting introduced due to the atmosphere. So these correction needs to be done. So for this type of correction, you need to know what was the atmospheric column at that time, and other things. So these kind of corrections are already done. So the data that we downloaded is radiometrically corrected. So we don't need to worry about that. So I just introduced you to know that these corrections needs to be done. Sometimes it is done, but basically these type of correction requires very high knowledge. So generally students don't do it. Some expert do it, and I also don't know how to do it. So I'll tell you how to do geometric correction. So geometric correction is also known as georeferencing, and this is the process in which your satellite imagery or other types of maps are georeferenced or aligned with respect to real geographic coordinates. So sometimes what happens is that suppose this satellite is moving, and there may be, while moving, the velocity might not be very constant, so it can introduce some geometric errors, or it happens is that there like earth is also rotating, so there can be shift in the, like, the image that we get is this, but geographically it is something like this because earth is rotating. So these needs to be corrected before we analyze the data. Okay, so we need to do georeferencing. So for that, there are certain steps. So first step is to locate ground control points. So some points which you can identify in any topographic sheet, then you should take those points, and then you should always calculate residual error. So these things I'll show you while I'll be doing practical demonstration using QGIS. So there the value will come. So the residual error is calculated. So it is basically the distance between the source GCP and retransformed GCP. So if this RMS error is greater than the spatial resolution, that means that ground control point is not correct. You should select another point. Okay. So first step is you should choose some ground control points, and then what happens is that in the software some calculation goes on. So based on which type of transformation you want to do, whether linear or polynomial, the calculation goes on, and then what this input image is retransformed into output image. Now the thing is the coordinates are changed now, but we also need to assign the DN values. So for that, this resampling is done. So it is basically assigning the DN values to the new output image. So there are various types. So first one is nearest neighbor, second is bilinear. So in nearest neighbor, you just put this DN value to this one. Okay. But in bilinear interpolation, you take these four values, average it out, and then uh, uh, give it to the output image. And cubic, you use 16 pixel values and then average it out. So now I'll show how to do it in QGIS. So if you want to use QGIS, first we need to install some plugins. So I'll just show you which plugins are required. So the plugins are Quick Map Services, Map Swipe, and Map Swipe, and there is one more. So first, this is the interface of QGIS. So first you need to go to plugins and then manage and install plugins, and then you can search quick quick map services. So as I have already installed this, so I don't need to install it, but if you don't have installed it, you need to install it. Then swipe map swipe tool, this has already been installed, and then you also need to install this semi automatic classification. See, so this one. So for installing you have to, there will be one option here through which you can install it. Yeah, okay. So as we have installed all the plugins that are required, now we will do georeferencing. So for that you need to have one image that is not georeferenced or any file that is not georeferenced. So uh, go to layer, and in the layer you can see there is this option georeferencer. So go here, this tab will come, and here if you see this option you can open raster, so you can add any TIFF file or any image that is not georeferenced and just add here. Okay, now through this option is for adding points, adding ground control points, and from this you can delete it. Okay, so first you have to zoom in. Yeah, and then so now you have to assign x value and then y value. So it will be 82, 35, and y value is 25, 5. Okay, and you can see the coordinate system is WGS84. If this is not coming, you have to first choose the coordinate system so that it can georeference in that coordinate system. Now, okay, so this point has been added, you can see. This is the GCP table, ground control point table. Okay, now you can add another point. So try to add at least 4 points, and before adding, zoom in so that you can, the errors are, this is 25.5 and this is 82.40. Okay, now go to add point, click here. This was 82.40 and this is 25.5. Okay, now go to the fourth point. Sorry, third point. Now add point, this one is 82, 35, 25, 0. Okay, add point, and this is 82, 40. So if you see this table, you can see dx, dy residal. So these are the residal errors that I was talking about. So if you go to this slide, see source GCP and retransform GCP, and this is the RMS error that is there. And if you look at this table, these are very small, so that means the resolution was 30 meter, and this is so this is not the data, but if it was a Lancet data, and if it comes out to be greater than 30, that means you have to discard that GCP. But in this case, we don't know, because this was just an image or a topo sheet. So it's good, it is low. Now what we have to do is that start georeferencing. Select the out. So here you can see transformation type. So you can choose linear, polynomial, or anything. So I'll choose polynomial one. This is the coordinate system, which is WGS 84. Now this is the output file. Resampling type. So I told you, for assigning the DN values, you can take nearest neighbor, bilinear, cubic, spline. So we'll choose nearest neighbor. Okay, now okay. So I think it's done. See, georeference successful. Okay, so if you You go to this image, this is now georeferenced. Okay, so any doubts in this part? Okay, suppose now you don't have any image, or whatever image you want to georeference does not have these coordinates written, because in this one it was easier because the coordinates were written here. So for that purpose, what you can do is that, suppose your study area is, so you can, first what you need to do is that you have to give um, the image that coordinates. So you can use Google Earth Pro and directly download your study area and then georeference it. So I'll just show you how in this one you can georeference. So suppose this is your study area. What you can do is that add place mark. Okay, and instead of this you can copy paste in the name, you can copy paste your lat long values. Okay, so for this one you can put this in corner and then change it. Okay, okay, similarly you can add another point here and then add the coordinates. Okay, so similarly then you will be having these coordinates also and your study area also, and then using the same steps you can georeference that. Okay, so I think I'll not repeat those steps. This was just a tip. Suppose you have a study area and it doesn't have any coordinates or any map that doesn't have any coordinates written on it, then using this you can do it. Okay, so I'll go back to the slides. Now I'll tell you how to do this step in ArcGIS. So this was done by QGIS. Now I'll tell how to do it in ArcGIS. Okay. Add a blank map and then use this to add your sheet. So first you need to connect the folder. So for connecting the folder you can use this, then go to the folder where you have kept the file. Okay, This is the folder. Oh, yeah, topo sheet. So you can see it cannot be projected because it doesn't have any uh, coordinates. So what you have to do is that you have to georeference it. So add it. Now you can see here these units are unknown. So what you have to do is that go to layers, then properties, and then the coordinate system you have to assign a coordinate system because it doesn't have any coordinate system right now. So go to projected coordinate system and then world, this one. Okay, then apply and okay. Okay, now this you should have this georeferencing toolbar. If you don't have, then what you can do is that right click here in the main panel and you have to see where is this georeferencing. You see, you have to choose this and this toolbar will come. Okay, so in georeferencing what you have to do is that from here you can add control points. So I'll choose this, but before that I have to zoom in. So I'll just go yeah. Then add control points. Now you can click here and then right click. So you can see there are these options. You can uh, go to this one, input DMS of lat long, and here you can provide the DMS value. So longitude is 82, 35, 0. This is north. Latitude is 25, 0. Okay, so the first point has been added. So if it is not visible, you can just right click here and go to zoom to layer. It will come back. Okay, now you have to add second control point. So first you need to zoom in. Okay, then add control points, then one single click and then right click, then input DMS. Now you can add the degrees, 82, 40, 0, and here it is 25, 5, 0. Okay, now zoom to layer and then at the third point, it is 82, 35, 25, Now we can go for the fourth point. Fifty to 40. So now you can zoom this layer. So we have added the 4 control points. Now you have to go to this rectify. So you can get this. It is asking what will be the resample type. So I'll go for nearest neighbor and then you can save it. And if you want to see the link table, so this is the source, this one is for the map, and the transformation is polynomial. Okay, so now you can go for update georeferencing, and now it's done. Okay, so this is how you can do georeferencing in ArcGIS. Okay, now I'll go back to the slides. So the first step of digital image processing is done, which is image restoration. So now I'll go for image enhancement. So in case of image enhancement, there are three types. So first one is radiometric enhancement, second is spatial enhancement, and third is spectral enhancement. So radiometric enhancement is based on the individual pixel. So suppose the lightning is uneven, so some areas can appear darker and some can appear brighter. So for this type of um, image, raw image, what we can do is that we can do stretching, contrast stretching, histogram normalization, or equalization. So there is this one example. So if you see this image, this histogram, this is the histogram of the original image. So this one is the original image. So you can see the DN value. So it was an image which has resolution of 8-bit, radiometric resolution of 8-bit. So the DN values will start from 0 and go up to 255. But if you look at the original image histogram, it is starting from 84 and going up to 153. Okay, so it is not covering the entire range of TN values. So what we can do is that for enhancing the image, we can stretch this such that this 84 goes to 0 and 153 goes to 255. So we can stretch this image and get an image like this, and this one is far better than this one because it has been stretched and enhanced. Okay, so if you want to this stretching, contrast stretching is of different types, and you can adjust saturation, brightness, and other factors, and it is not like there is not any defined protocol. For each image it will be different, contrast will be different, brightness will be, so you have to adjust it. So it's better if you know color characteristics. So there are three color characteristics, which is hue, saturation, and brightness. So hue is the dominant wavelength. If you see this cone, hue is this one. So it gives through this you can identify what will be the color. Saturation um, shows the purity of the color. So if it is red, completely red, it means it is pure. But if it is mixed with white and pink, then it will be pink color is white mixed with red, so it is not pure. So saturation is that. And brightness is the amount of light reflected. So if it is um, 0, that means it will be black. If it is brightness is high, it will appear white. Okay, so this concept will come later when we will do this contrast stretching or stretching in QGIS. Okay, so that's why I told you. Remember this. Now we'll see what is contrast. So if you see these three images, they are from the same area, but they have different contrasts. So if you look at the histogram of these three images, you can see in this one, so in this one, the DN values are low. That means it is mm, closer to the darker side. Okay, so because 0 is completely black and it is not going up to completely white part, so it is appearing black or darker. Okay, now if you look at this image, it is brighter, and if you look at the DN values, it is like skewed towards the higher DN values. But if you look at this image, it is like it is covering the entire range, and its contrast is good. So for contrast stretching, you have to look at the histogram. So how the histogram is looking, and then you have to stretch it such that it covers the entire range of DN values. Okay, so there are different kinds of contrast stretching or enhance radiometric enhancement. So first one is linear contrast stretch. So if you see this original image, the DN value is from this to this. So it's like DN minimum. It's starting from this. So this x-axis is representing input image DN. So its range is starting from here to here. So that means it is from here to here, DN min to DN max, and this is our y-axis is output image DN. So it will cover the entire range from 0 to 255. So if you see the histogram, it is starting from 0 to 255, and if you see here, the points are covering the entire range. So this is called as lookup table. So you can see in the contrast stretch, this is linear contrast. This is linearly stretched. So the distance between these two, like the curve is kind of identical, but it has been stretched. Okay, so linearly. In the histogram equalized stretch, this is the formula that we use, and if you see, this histogram is not exactly like that because it is not a linear one, but it is also covering the entire range. Okay, and then there are other types, so I'll not go much into the details of this, but these options will come when we will do uh, contrast stretching in QGIS or ArcGIS. Okay, so first of all, I'll tell you how to do contrast stretching in QGIS, and then I'll tell you how to do it in ArcGIS. Okay, so so first I have to open QGIS. Okay, now here also you can, like, you have to go here, somewhere here, main panel, and then right click, and then look for raster tool. So these are the toolbars. Oh, raster toolbar. So it was available. So this you have to activate. Now you have to add the image that you want to stretch. So you can just go here, open data source manager, it will go here. Then you can add a raster data set. So I'll just add the data which I have downloaded. So this is band 1. I'll just add all the 7 bands, then open. You can add just one band also for stretching. So now what you can do is that you can zoom in your area of interest. So suppose this is the lake. This is my area of interest. Then you can go to this cumulative cut stretch and then go to this one, local cumulative cut stretch. So see, this has been done. So it is not appearing that. So maybe I'll add just one image that is color composite, or so on that one the contrast will appear and you can see it. Okay, so I'll just remove these. Remove layer. So this is the composite. So I'll just create a band. So this I will tell you later also, how to make false color composite, how to make true color composite. So right now just for telling you that the stretching is, if you see this image and now do the same step, you see. So in this one it is more evident that though stretching is having any effect or not. So in that one it was all gray, so it was not that visible. So that's why I pulled this one, composite image, and then I showed you. Okay, so this is like uh, there is one more way to do this stretching. So and for that one you can just right click here and go to properties and then symbology, and here you can see that there is this contrast enhancement option. So you can click on no enhancement and then apply. Now if you see this image, it is, see, it is not visible at all. If you apply this one, so min max is linear one, you see. So you can change this to do the enhancement. Now you can also change this contrast levels. So first I have to apply no enhancement, and then you can change the contrast, maybe increase this, increase brightness. So this all is like it is decreasing. So there is no specific rule. So based on like your image, you can do it. So change it. So change it till you get the desired result, but that one is better, that direct one. Okay, now if you go here, if you have applied no enhancement and put the value 0 here, then you can go to histogram from here and then compute histogram. So say uh, in this one these values are starting from here, somewhere here, and then it is going up to here. So you know how to do it. So you can change this min max and then this enhancement will change. So it is getting zoomed in. Okay, now it's okay. So it is starting from somewhere here and going up to here. So you can see this one min max value is coming. So you can apply this and change for other bands also. So you can see you can pick this minimum value. So this is the value. You can drag it to this was the maximum value. You can pull it to here and then apply. So you can change it for every band. So it will take a lot of time. But this is how you can do. You can change the minimum and maximum value for the histogram for each band and then apply it. But the better method is just go here, contrast enhancement, and go to this and then apply. Go to this, then apply. You can see the changes. Okay, so this is how contrast enhancement is done in QGIS. Now I'll go to the slide. So this part I have done. Now we'll see how to do contrast stretching or contrast enhancement using ArcGIS. So, so it is more easy to look at the histogram in this one, ArcGIS, as compared to that one. So this is only my view. Okay, so now you can add the layer. Zoom in. Go to properties. Here you can see histogram. So you see these all are here residing on the lower DN values. So that's why it's appearing slightly darker. Maybe you can change these bands. And then what you can do is that you can change the stretch type. So if you choose histogram equalize, then apply, you can see now this one is looking better. See. And if you go to the histogram now, So this one was the previous histogram, and these red ones are the histogram of the output image. Okay, so you can see now. Suppose we change this to different min max, which is linear. Now apply. So min max is, so now it is now none. For that, the histogram is like this. Okay, it is starting from here, going up to here, 4000, and going up to 33 something. And then if you go for this min max and then apply, it is same. I don't know why. Because we can change it. So if you will change this to go up to here, you can see it can change. Okay, so it's up to you. You can customize the changes also. So if you see this, now it's custom because you are the one who is changing. So now you can apply. See, this is the effect. Okay, so the best one that I found was this one for this image. Histogram equalize. Apply. Okay, so it's good. Okay, so this is how you do contrast stretching. So for the stretching, you should look at the histograms of the input image and then output image, and like you can use different kinds of stretching, and then whichever works best for that particular image, you can apply that one. Okay, or you can customize it also. So I think this part will be clear. Now we'll go for spatial enhancement. So spatial enhancement is based on individual and neighboring pixels. So suppose the objects or textures are blurry, so we can employ different filters like low pass filter or high pass filter to smoothen or the image or sharpen the edges. So if you see this image, you can see we have applied two different kinds of filtering in this image. The first one is high pass filtering. So this kind of filtering enhance the edges of the feature. So you can see the boundaries have been enhanced, and the low pass filtering smoothens the picture. So for this one, I'll just show you dips, like how the back calculation is done in this software. Okay, so you can go to this filter explorer. So if you see here, there are these two options, low pass and high pass, and this is the input image, and this is the image, or how the image will appear, and then this is the like filtered image. So right now it is same as this one. Now what we will do is that we'll run the filter. Okay, so it is, what it is doing is that it is taking this 3 by 3 matrix and then multiplying it with this one, this filter, low pass filter. So this is the calculator, convolution calculator. So you can see each of these are multiplied by 1, and then they calculate filter sum and then average it out, and whatever will be the final output, it will be assigned to this. So see, this 80 has been changed to 63. Now if we run for the other one, it will change to 69. So you can see these higher values are now getting lowered. So it is kind of smoothening the image. So if I do it for every image, you can see this is now uh, getting smoothened. Okay, so this was something like this. So the stretch was on here, so that's why I stretched it also. So if it will be off, then here it should be off. So now you can see this has now been smoothened. Okay, now you can copy this image and then run the same filter. Now what will happen is that it will further get smoothened. Okay, so this is the final image. So it is getting smoothened. Okay, see, smoothened. Now what you can do is that you can apply high pass filter to this. Okay, now run the filter. So what it is doing is that it is giving weightage to the middle value, and then -1 is multiplied to the outer matrix. So it is kind of enhancing. Okay, so it will, the values will increase. If you see, it was 65. This one is 62. This one was 59. It will become 64. So this value is increasing. See, okay. So this is how this filtering is done, high pass and low pass filtering. Okay, so now I can show you how it is done in ArcGIS. Okay, so open ArcGIS. Open a blank map, then go to customize and then extension, and then click on the spatial analyst tool. Okay, so it's already clicked, so close this. Now you can go to arc toolbox. It's opening. Yeah, so in arc toolbox you can go to spatial analyst tool. Okay, and then you can go to neighborhood and then go to filter. Now double click this, it will ask what will be the input raster. So you can just add any file. So I think first you should add it here to see how it is looking without having any filter. Okay, so I'll just zoom in. Now you can go to the filter, add this, and then apply high pass, so that, or you can apply low pass filter, and then it will be change the output location. Okay, and then click OK. So it is going on, but it never shows whether the calculation is going on or not. Okay, if you see this image, you can see this edges. So these were the mountain ranges, and these edges has been enhanced. See, so this is how this filter works. So this enhances the edges. Okay, and if you apply the low pass filter on the same image, go here, apply low pass filter. Now it is showing here. This will smoothen the image. See, now I want to see what will happen if we apply this filter on high pass filter. I don't know what will happen. I just want to do it. So it is applying low pass filter on the result of high pass filter. You can see in this one the edges were clear. See, now they have been smoothened out. That's why it is appearing slightly blur. Okay, you can see the difference of this spatial enhancement or filters. Okay, so I'll just go back to the slides, and now we'll go for the third kind of enhancement, which is spectral enhancement. So this is not based on only one band image, so you have to uh, look for other bands too. So suppose the if you see one band image and there is no any feature that you are able to detect, or there is some difficulty in feature detection, what you can do is that you can combine um, the information from different bands and then make a color composite or calculate index or calculate band ratios, and then uh, use that in composite or indices for feature detection or classification. Okay, so this is one example which is for false color composite. So you can see these are the 7 bands that we have downloaded. Now what we will do is that for creating a false color composite, we will assign near IR a red channel, and the red channel a green, uh, a red band a green channel, and this green band a blue channel, and then make a color composite and then see how it is looking. Okay, so first maybe I'll go to ArcGIS because it's open. Okay, so I'll just remove these. remove it, and then add bands. So you can see this one is the Landsat data band 1, then choose band 2, 3, 4, 5, 6 and 7. Okay, now you can add this. So you can see all the bands have been added, and now you can go to Arc Toolbox. Sorry. So yeah, so what you have to do is that go to this Arc Toolbox and then raster. So where was that toolbox? Okay, Arc Toolbox, and then here is raster. So I have to, okay, data management. I forgot data management tool, and then go to raster processing, and then here you will find one option which is composite bands. So here you can select all the bands, 1, 2, 3, 4, 5, 6 and 7. So I have added all the bands, and output raster you can choose FCC or TCC, anything, and then click OK. So it is making the band composite. We have to wait. It's taking some time. It's taking so much time. So I wanted to ask whether all the steps are clear or not. Or you can ask any question if you think there is any problem or something that you are not able to get it, because I'll also give assignments based on these. So it's better that you ask the questions now. Okay, so I have removed all the layers because I got my composite band. Now what you can do is that you can just right click here, go to properties, and then you have to assign all the channels one band. So for false color composite, or suppose I want to create true color composite, then I'll assign this blue band will be 2, this will be 3, this will be 4. Okay, now apply, and this is the true color composite. Okay, now if you want to create false color composite, so the reason why false color composite is preferred is that it will assign a color blue to water bodies, red to vegetation, so that is more easy to interpret. Okay, so because it is assigning near IR a red channel, and near IR is very much reflected by these vegetation. So you can see, if you zoom in, this is the lake, so it is blue in color. So if it is not that visible, what you can do is that you can apply stretch, contrast stretch, and this image will enhance. Okay, so you can go here, go to histogram equalize, and then apply this. Now you can see this one is blue, so it is water body. This one is red because it is vegetation. So these parts are covered by vegetation. So it is reflecting near IR, and near IR is assigned a red channel. So that's why it is appearing red. Okay. So this is how you create true color composite or false color composite in ArcGIS. Oh, so now I can open QGIS. So now I'm talking about this. So open QGIS. Now first you need to add your raster data. So you will go to that open data source manager, then raster data sets, and then you can go to the data. So you can see there are 11 bands. Now we will choose the first 7 bands, 4, 5, 6, 7. Okay, open, then add, then close. Now these bands have been added. Now you have to go to this. Where is that plugin? Okay, so I'll just search here. Semi automatic classification plugin. You can reinstall it. then close. Okay, so here you can go here band sets, and this will appear, and then you have to add your bands. So these are the bands. It copied the 5 bands: B1, B2, B3, B4, B5, B6, and B7. You can add these, and then you have to go to this wavelength and choose the data set you have downloaded. So I have downloaded Lancet 8, so I'm choosing this. But if you download another data set, you should um, like choose that one. Okay, so this is Lancet 8 OLI band. Now you have to click on this create virtual raster of band set, and then create raster of band set, stack bands, and then run. So it will uh, ask you like what will be the folder. So you can choose any folder. So maybe I can create one FCC, and then choose this folder. Okay, now it's creating this band composite. Okay, now what I have to do is that add that one, because it has created but it's not loaded in QGIS. So I have to go. Well, this was the folder that I created. So in some like in some of yours laptop it will automatically get added, but in mine it is not getting added. So I'll just go here because it has been created. I just need to add this, open this, and then close. Okay, now if you see, this has been added. Now you can remove the other layers. Okay, and then right click, go to properties, and then you can assign band 5, which is near IR, to red, and band 4, and this one will be band 3. So always don't assume that band 5 will be near IR, because in different kinds of um, satellite data, different bands are assigned different wavelength ranges. So you need to check which band is corresponding to which part of EM spectrum. Okay, so in case of Landsat 8, this band 5 is near IR. So that's why I am doing this. Okay, so always check before you assume. Now you have applied. If you now zoom in to this area, so you can see it is appearing slightly red. Now what you can do is that just zoom in the area and then do the stretching here. Now you can see this. If we are creating FCC, then what this water bodies are appearing blue and vegetation is red. Okay, and this is no. Now you can also create true color composite. You just need to change the bands. So this will be band 4, this will be 3, and this will be 2. Now apply. Okay, and maybe you can just go and stretch it, or you can directly stretch it. Okay, see, in true color composite, this is not appearing as blue. Okay, so that's why this FCC is preferred sometimes. Okay, now I'll go back to the slides. And we will now see what is NDVI. So NDVI is Normalized Difference Vegetation Index. So it is used to study the vegetation health. So green and healthy plants absorb visible light for photosynthesis and reflects large amount of NIR. So, so this NIR is band 5 in Lancet data, and the red band is that one, band 4. Okay, and if the plant is stressed or unhealthy, it will absorb very little red light, and it will not reflect much amount of near IR. So based on these two bands, near IR and red band, these index has been introduced, and it is near IR minus red divided by near IR plus red. So higher the index value, the healthier the plant is. Okay. So now if you see this image, this is the spectral reflectance curve of vegetation. So you can see there are three curves. So this one is for healthy green vegetation. This orange one is for stressed vegetation, and yellow one is for severely stressed vegetation. So if you look at these two bands, near IR and visible, you can see this healthy vegetation is having high reflectance in this near IR range. And if you go for severely stressed vegetation, the reflectance in near IR range is decreasing. Okay, and if you now look at this um, part, which is visible part, so as the vegetation is getting stressed, there is a blue shift in red edge. So this is the red part, and there is shift in this edge. So if you consider this as edge, this is getting shifted towards the blue end. So this is called as blue shift in red edge. So these two parts are considered for studying vegetation because they are affected based on the vegetation health. Okay, so you can see this healthy leaf is reflecting more of an NIR and very little of red, and this dead leaf is, so as the vegetation health is decreasing, this near IR is decreasing, and this red one is increasing. So this can be used for creating NDVI and can be used to study vegetation. So if you use different satellites, then different bands correspond to different range of EM spectrum. So if you have taken Landsat 4 to 7, then NDVI will be band 4 minus band 3 divided by band 4 plus band 3, because this band 4 is near IR, but in case of Lancet 8, band 5 is near IR. So as we have downloaded Lancet 8 data, so I'll be using band 5 and band 4 for creating NDVI. But if you are downloading Sentinel-2, then this will be completely different. And in that one, band 8A correspond to near IR and band 4 correspond to the red band. So This is how you can do. So now I'll show you how to do it in ArcGIS, and then we will go for QGIS. Open a blank map, and then first you need to add the bands. So which bands are needed? For this one you need band 4 and band 5, because we have downloaded Lancet 8 data. So band 5 is near IR and band 4 is red. So these two I will add. Okay. So now you can go to Arc Toolbox, and then go to Spatial Analyst, and so maybe I should zoom in so that we can see the differences. Okay, so I'm zooming in this part, and now I can go to Arc Toolbox, then Spatial Analyst tool, then there will be a raster. Okay, so I'll just check. So first I need to go Spatial Analyst and then Map Algebra. Okay, so I was missing one step. So it was Spatial Analyst, then Map Algebra, and then Raster Calculator. Okay, so you can see the two bands which we have added is now appearing here. So this is in the layer and variable column, and now what you can do is that this one is band 5, this one is band 4. So first you need to select float. Okay, and in float you can add band 5, and then near IR minus red. Okay, so band 5 minus band 4, and then come out of this float and then divided by, then again float band 5 plus band 4, and then have to click OK. Now first you need to provide output raster, where it went. I don't know if it is doing the calculation or not. I think it's doing, but I didn't provide it the output raster file, which I should have added here. So I think it is creating a temporary file which is here. So if you see, these values are uh, from this range. High is 0.4 and low is minus 0.277. So the NDVI range is between -1 to 1, and it is appearing within the range. Now if we go here, because right now we are not able to distinguish much, then what we can do is that we can classify this. So go to symbology and classified, and then you can assign the color. So high value means the vegetation is healthy, so we can assign it a green color. Okay, then then the negative value is like dead plant. I've assigned it yellow color. Now you can apply, and now you can see these. So the areas which were appearing red earlier when we were creating false color composite are now appearing green. See, so these areas are now appearing green because it is having the vegetation. So the NDVI value is coming out to be high. And in case of bare soil, it comes near around 0. So that's why this part, which is this um, this is the lake, and this is dried lake basin, so that's why it is around 0. And this one is, which is yellow, is negative value, and this is because the water bodies, and if you go for ocean, then the NDVI value comes out to be -1. Okay, because it can't absorb the near IR. Okay, because it absorbs the near IR and doesn't reflect. Okay, so that's why. So this water body is appearing to be yellow because it is having negative value. Okay, so this is how you can create NDVI in ArcGIS. Now I'll tell you how to do it for QGIS. Okay, so you can see I've written also an ocean will yield NDVI of -1, but as it is a water body, um, and so that's why it is also having negative values. Okay, now I'll create NDVI using QGIS. So first of all, you have to add band 4 and 5. So I'll remove this layer and then add band 5 and band 4. Data band 4, which is red, and band 5 is near IR. So now I have added. Now you have to go to raster and then raster calculator. Okay, so now in this one, these are the operators. Maybe I can shift this so we can see what is the raster calculator expression. So first you need to select band 5, then minus, then band 4, close the bracket, divided by band 5 plus band 4. Okay, now you have to provide output layer, file name and location, and then you have to also add coordinate system, default, as sourced, and then OK. Okay, I think there is some error, so I'll just do it one more time. So first of all this, then band 5, minus band 4, plus band 4. Okay, close the bracket. So I think it has created NDVI, but it was not able to add to the project. So I'll just add it to see if it was created correctly or not. Okay, so I'm adding this diff file which was created previously, and okay, go to properties. So the values are strange here. Maybe I'll do it one more time. So let's see what were the steps. First of all, I have to import the raster data and then load the data sets and then go to raster and then do this. There is nothing else that needs to be done. Okay, so I'll try one more time. Raster, then raster calculator, band 5 minus band 4, close the bracket, band 5 plus band 4. Oops. Okay, so create it here, NDVI, enter. Now the output format is this. Okay. The error is that it is not able to transform this box to the target coordinate system. Okay, so maybe I can check this layers coordinate system. It is this one, 43. Okay. So maybe I'll apply to use the same coordinate system. So these things we need to take care of, because if the coordinate system is not matching, then there can be error. Okay. So band 5 minus band 4. Okay. And then it will be 43. But okay, this one is having this error, so that's why this was not coming. So now I think it's calculating, and the problem was that the coordinate system was not same. So sometimes it can happen that if the coordinate system is not matching, then you can run into an error. Okay, so now we will do the same for this one. Like you can see the range is starting from 0.37, which is almost equal to that one, previous one, zero point 0.4, and going up to minus values. Okay. Symbology, color gradient. So now it has classified it, but we don't want these many classifications, I guess. But still, you can see these has been classified. So the thing is that you have to just classify into 5 colors, so you can just delete these values. Okay, just you need to do this. So it will reduce it, and then you can apply. It's loading. So there are so many colors, you need to reduce it. So just click here and then minus, minus, it will reduce. And and just make it 4 or 5 classes so that you can easily identify. So I think it has stopped responding. I'll just wait for a few seconds. Okay. So this is how this will be done, because as it is having so many colors, it's taking time. Okay. So I'll just stop it. Yeah. Close the program. So now we know how to do NDVI using QGIS. But this is not the only index that we can use. So there are so many different indices. So if you click here, you can go here and you can see aerosol free vegetation. So if the vegetation is having any aerosol particles on it or not, that also you can calculate. So many indices have been introduced and you can use any of these. The thing that you need to know is that which band you should be taking. So in this one, if you see chlorophyll vegetation index, so for that one you need to use this red near IR and green color. So you know red in Lancet 8 is 4, green is 3 and near IR is 5. Now if you want to calculate coloration index, you can use this. So this is the uh, list of available indices, and you can use any of these based on what you are aiming to do. Okay, you can see there are other vegetation indices also, green, mid, IR. There are different vegetation indices. Modified NDVI also you can take. So now I'll show you what assignment I'll give based on this practical session. So till now we have covered this image restoration and image enhancement in digital image processing. In the next session, I'll cover image classification and how to do how to make land use, land cover, change map, and how to make digital elevation model, how to make shapefile, how to do like how to make spatial plots using different interpolation techniques. So those things I will cover in the next session, which is on Wednesday. So this is the assignment that is based on this. So first you need to download the satellite data. So I've given you that link, USGS Explorer. So from that you can download like whatever any satellite data that you want to use. Then you have to write the information about the resolution and what is what was the cloud cover. So whether you have taken uh, an image with low cloud cover or high cloud cover, that also you need to take care of. And then like what is the resolution, 8-bit image, 2-bit image, 4-bit image, what is the radiometric resolution, then what is the spatial resolution, 30 meter or any other. So these kind of things you need to write, and like this can be accessed. So I showed you there is this one metadata file, so there you can, I'll just show you one more time. So like suppose you have searched for the data for the location, and now what you need to do is that you have to go here, show metadata and browse. So it will show you this data. So here you can see these kind, when what is the date when this was acquired, and then nadir of nadir. So these kind of things you can see here. Okay, sensor type and different things you can. And then you also have to write from which uh, site you have downloaded the data. Okay, and then using that data you have to create like one index calculation. So do one index calculation. So I did for NDVI. So similarly you can choose for any other index. So I've shown you this one, this list. So you can choose any one index that you think I can do it, and that has some application. Okay, so you have to read about that index, apply it, calculate it, and then report any observation that you uh, see for your area. Okay, so I don't know. Okay, now what you have to do is that then you have to perform the analysis, like the calculation for that index, and report any observation that you observe. So you have uh, to do this calculation, index calculation, and then you can apply contrast stretch on this one also, and do it for the false color composite of that area. So you have to create false color composite and then apply this stretch, contrast stretch. Okay, and then in the report that I'll be correcting, you have to add images before and after analysis and write your observations. So this is the assignment that you have to do. And Raj Lakshmi ma'am, are you here?
Yes, yes,
Yeah,
Akansha, can you hear me?
yeah. So can you tell
You
like
have,
how much time? Uh,
yeah, I have posted the OneDrive link as well as the timing is mentioned here till tomorrow evening 6 p.m. That's fine.
mm-hmm.
Is it
Okay.
okay? Time is okay?
Yeah. It's okay.
Yeah.
Okay for me.
So we'll wait till tomorrow evening 6 p.m. and post it. You can start the evaluation for this
Yeah.
one. And I hope there
So,
is one question posted by Dr. Ram that can just answer this query.
okay. So when people go for crop identification or classification, in general, they choose modified NDVI, whether it is appropriate. So he's asking like whether for crop identification and classification, they can choose this modified NDVI, or like you can combine different type of vegetation index, like you can go for this normal NDVI, modified NDVI, and then you can see there are some other indices also for vegetation, chlorophyll and all. So based on your crop type you can choose, like you also have to look for the properties of the crop, like uh, suppose um, if there has been study that if the chlorophyll content of that crop or that plant is high, that means it is having a better vegetation health, then you should go for this chlorophyll vegetation index. And maybe you can also go for this cellulose, or like this is based on what kind of crop or which crop you are looking to. So the best way is for me is that you look for some literature which tells that for this kind of crop this vegetation is the most appropriate, and then you can choose. So yeah, so I hope I have answered your question. Yeah, thank you. Yeah, so first you can look for the paper, and then you can see like these maybe combination of these three indices can give me better result, so you can just go for that. Okay. So for this report, you only have to do any one index. So not that much detail is required. Any other questions from anyone? So in the next class, I'll just tell you the next class what will be I covering. Or if we have time, we can do it now. Rajlakshmi,
Aakanksha, I think we can
yeah,
wind up for today's session and we'll continue the same for Wednesday, the same timings.
yeah. So that's what I was thinking, but I thought like it's 8:41, so whether I should wind up or not. Okay. So yeah,
Yeah, I
so
think we can wind up.
yeah,
In case
yeah,
of any queries, we can let them post. This is the chat that is being created in Teams. So in case of any queries, they are free to post it here and you can answer it.
yeah. So you can answer, and just meanwhile I'll tell what I'll be covering on Wednesday. So I've
Yeah, sure.
I've completed till this NDVI, and in the next session I'll start with image classification. So now as we have enhanced the image and restored it, now we can classify it in different land use, land cover types. And then I'll also tell you how to create shapefile for your study area of interest, how to make spatial plots. Like if you have data for your area of interest, how can you make spatial plots? Okay, so that, and you can apply different interpolation techniques. So for this, I will use IDW, and then I'll also tell you how to download digital elevation satellite data. So I think I'll be downloading for from Woven or Cartosat, and then how to create digital elevation model. Okay, so if I guess there might be some questions, I don't know. So you can ask questions, or from the assignments part also you can ask, like if you have any doubt in any step.
Maybe Akansha, we can give them some time while doing their assignments. They'll be getting more doubts, I guess.
Yeah, while doing they will be getting more doubts. Okay,
Yes.
okay. Yeah. So I think that's
So,
it for today. Okay.
yeah. So,
Yeah.
thank you so much. That was a good session.
Okay, thanks. But I
Thank you.
thought
So,
students will be interacting more, but they are not
uh,
interested. So
I guess we're doing the assignments. They'll get on more. Maybe on Wednesday, they'll come up with some doubts or clarifications. We'll wait.
yeah, sure. So
Yeah.
yeah, okay.
So, thank you so much. So,
Thank
we'll
you.
wind up today and we'll start by Wednesday, the same timing and same link can be used.
Okay. So thank you everyone.
Yeah.
Thank you, ma'am, for
Thank
having
you.
me.
Thank you.
Okay.
Thank you,
Oh,
Akansha. Bye
okay. Bye.
bye.